Today's notes are on unfoiling or factoring trinomials. And so to start, we're going to start with a demonstration of what normal foiling is, because if we're unfoiling, we just need to do foiling backwards. So I'm just going to make a question up really quick, maybe x plus 2 and x plus 5. And if we were going to FOIL this, remember we've learned it this year, you're going to get 4 different things, and then you're going to combine those middle two. So we're going to get, first of all, x times x makes x squared, and x times 5 makes 5x. Then we're going to move to the 2, and we're going to do 2 times x, and we're going to do 2 times 5, which makes 10. And that's foiling, and we've done that. We're not quite finished yet, because our answer, we need to combine these middle two terms together, right? 5 and 2. And when we combine these middle two terms together, we're going to get x squared plus 5 plus 2 makes 7x plus 10. And this is the answer. Now, if you look at the notes for today, that's not the answer anymore. That is now the question. And that is where we start. So we've already done these questions, right? Where you start with the parentheses, and those questions are called foiling. What we need to do today is start with these trinomials at the bottom, and we need to go back to the top. And that is our goal. Start with the triple with the x squared and break it down into the parentheses. So when we look at this, first of all, our answer is going to look like this. Parentheses, parentheses. So you can go ahead and write those parentheses down and get that ready. The other thing is that just like when we do foiling, it's going to start with x in that left position every time. So you can also start right here with x in the left position every time. And so if you get this far, we haven't had to do anything specific to the question, and we've already got a lot of this figured out. Now, at the same time, I had a student in first period turn in a work with no parentheses on it. I don't know how they got there, but they got a 0%. So every question is going to look like this, okay? Now, then these two positions is when we need to choose the two numbers. So there's like two little numbers, two answers for each question. And so again, if we think about this FOIL example that we did before, it was 2 and 5, that makes 7 and 10. Now, here's the part where you want to listen and check this out. If we start with 2 and 5, how do we get the number 7? You just added them up, right? What is 2 plus 5? It's 7. So this middle number right here happens when we add them together. If we start with 2 and 5, how do we get to 10? Thoughts? If our two numbers are 2 and 5, how do you get 10? Multiply. What's 2 times 5? 10, of course. So what we've got here is an interesting little puzzle, okay? These two numbers add together to make 7, and these same two numbers multiply together to make 10. So this is like a nice little puzzle, and actually when I was learning math, when I was in Algebra 1 as a student, this was the very first thing I learned where I was like, you know what, this is kind of cool, like this is kind of clever. I have to be a little bit smart here. I have to solve a puzzle. So what we've just figured out is that we need to figure out two numbers that add together to make 16 and multiply together to make 63. I'll give you an example. What about 6 plus 10? So, 6 plus 10, Josh, we're doing a lot of talking, I feel like. 6 plus 10 is 16, is 6 times 10 equal to 63? No. So this right here is a wrong answer because 6 plus 10 makes 16, so that's good. But I need them to multiply to make 63. So 6 and 10 is not right. Are there any other numbers that add to make 16? What do you got? 7 plus 9, Jacob says. What is 7 plus 9? 16. And hopefully 7 times 9 is 63. So this is the perfect combo. This is the solving of our puzzle. And we get 7 and 9 is the answer. So we want to put 7 and 9 in here. And just so you know, the way we like to do it is put the big number in the first position. So we're going to go with plus 9 plus 7. A little bit of a puzzle. And sometimes that's really easy. Like look at number 3. I think everybody, if I gave you 5 minutes, could figure this out. Okay? We're looking for two numbers. They have to add together to make 15. And those same numbers have to multiply to make 50. Can anybody solve this puzzle? And Tyron's got it. 10 and 5. What is 10 plus 5? Oh, hold up. Give me a sec. 10 plus 5, 15. And what is 10 times 5? 50. It's the perfect puzzle, right? It can be a little bit tricky. Sometimes, though, it's not too bad. Now, if we look at the rest of this, and here's where I really would like you to kind of pay attention a little bit more. Every single one of these has negatives now. Negative 7, negative 8, negative 3, negative 4, negative 21, negative 56, negative 27. All of these other 6 have negatives, and the negatives makes things a lot harder because you got to keep in track in your mind two numbers that add and subtract to make, and it gets very hard to do in your head. And so here is the secret. All right, here is the Desmos solves the whole thing for you. Instead of doing it like this, 10 and 5, where we have to guess the letters, what we can do with Desmos is make Desmos tell us these numbers. So we're going to delete 10 and 5, and we're going to replace it with x plus y, and delete this, and replace this with x times y. So now, using Desmos, we're not giving Desmos those answers. We're going to ask Desmos for the answers. Now, right now, Desmos doesn't have any idea, right? Because Desmos doesn't know, like for number 2, that we have negative 7 and 12. Out of these two numbers, negative 7, is that the add or is that the multiply? If you look on the sideboard, I even wrote it for you there. The middle one is the add every time. So since this middle one is the add on Desmos, x plus y equals negative 7. And since this last one is multiply, we're going to put x times y equals 12. Now, when we do that, we will be looking at a crazy looking graph, but as always, we already did systems. If you have two different graphs, the answer is where those graphs touch each other. So for this question, maybe I change it to red. We're looking for where does red and blue intersect. Click on one of the lines. Now I want to really, ask you this. Is this dot right here where red and blue intersect? No. And if you're zoomed out so far that you can see negative 1,000, can you tell which one of these dots is right? No. So press the home button. This is where they touch at -4, -3. Now there's another dot where they touch. Look at this. But that answer has the same two numbers. They're just opposite orders. So you can go with -4, -3, or -3, -4. It's the same thing. It's those two numbers. But we like to put the big one first. And we're just keeping it simple, thinking about it like a kindergartner would think about it. 4 is bigger than 3. So we're just doing it like that. X minus 4, X minus 3, and we're done. All right, number 4 has Y's on there. That's a little funky. Let's skip number 4 for now. Let's do number 5. A good way to start, get your parentheses down. Put your X's in the first position. Once you've got your X's down, once you've got your X's in the first position, all we need to do is take the number 4 and take the number -21 and get them in here. I'll delete the old stuff. It's a +4 and a -21. +4 in the adding position, -21 in the multiplying position. Again, I don't care how crazy this picture looks, wherever they cross is where you have the answer. There should be 2 crosses and you'll get the same thing, just kind of flip-flopped. So we've got -3, 7, or 7, -3, and so 7's bigger, plus 7, minus 3. Now, I want to show you really quick what happens if you mess up. All right, so what happens if I accidentally put those in backwards? -21 and 4. Josh, you got to wait till the end of notes, man. We got 4 questions left. If I put these in backwards, I get the answer, and where they touch looks like this, -20.808. Do you think that's going to be a right answer? No. If you type it in wrong, it's going to be very clear that it's wrong. So, low-key, there's no way you even get this wrong. Even if you do get it wrong, it's obviously going to be wrong. The real thing that you have to be careful for is the negative signs, okay? Because what happens if I forget my negative sign? Now it just gets all kinds of a mess, okay? If I make it 4 and 21, if I forget my negative sign, it doesn't seem like they touch at all. Or sometimes they will touch and it will just be the wrong answer. So, long story short, type this stuff in Desmos and you'll get it right every single time. The setup is X plus Y, X times Y, and just make sure your negative signs are in there correctly. So, I'm going to give you guys a second, maybe 30 seconds. I want you to try number 6, parentheses with an X, go to Desmos, delete out this other stuff, and then put in the 2 other numbers, -3 and -4. Try it out, use Desmos. I'll give you another 25 seconds or so. You trying it? From good? You started or plug it in or something? Okay. Yeah. Use your words, you can do it. Anybody got the answer? Yeah. Okay. You got Desmos?
Are you able to get on Desmos?
What's up?
Press the digits.
Pretty much just like that?
He said number 4.
Just like a little bit back, where you almost got it.
You said number 4, right?
I meant number 6, if I said number 4. Alright, that was, I think, enough time. Quiet, please. Here we go. Looking at number 6. We need to use these 2 numbers, and they're both negatives. Do not forget the negatives. The middle one is the add number, and the end number is the multiply number. So on Desmos, this is my add, that's -3. This is my multiply, that's -4. I don't care how it looks, just click on where they cross, and I see -4, 1, 1, -4. Obviously, you're always going to get the same thing, just kind of flip-flopped. And so, big number 4, small number 1, just keep your negatives and your positives in the correct spot. And again, they could go in the other order. It's not really wrong if it's in the other order, but we do it this way because this is the way it is on like the SOL test with the big number first. Okay, we're pretty much done, all right? I want to show you how to do number 4. Number 4, parentheses, parentheses. The only scary thing about number 4 is that it has y's on it. And it's not that scary, but it's definitely different. You know how we start off like this with the x's on the left? What do you think the y's on the right are going to do? They're just going to put y's on the right. And we're just going to put our number in the middle like we always do. So the y's literally add 0 difficulty. You just start with x's and then you start with y's. Then you go to Desmos, it's -8, 16. So I go here, clear this out, -8, 16. Now this one I only see 1 dot because it's -4, -4. And what happens if you flip those around? It's still -4, -4. So the answer here is going to be -4, -4. Okay, that is everything. What we're going to do right now is we're going to start a timer and we're going to see how long it takes us to do 2 questions. Stopwatch, Google please work. Nice. Ready, set, here we go. Question number 7 is 1 and -56. Desmos, delete, 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 delete. 1, -56. Look at where they touch. -7, +8. X plus 8, x minus 7. Up next is this one. It's a -6, -27. This question has the y's, and that literally takes me 2 seconds. X, y, x, y. I'm going to use -6 and -27. -6, -27. Look at where they touch, and they touch at -9, +3. -9, +3. And those 2 questions took us less than 1 minute. That included a y question. These are not long. They are not hard. You use Desmos. The Desmos solves the puzzle for you. I just want to point out one last time, these are not random numbers that Desmos is making up, right? Desmos is just solving the puzzle. What is 7 plus -3? It's 4. And what is 7 times -3? It's -21, right? This is still the same puzzle we talked about. Add them up, multiply them. We just use Desmos to solve the puzzle. All right, that is trinomial factoring, aka unfoil. Not too bad.